Good morning, CP Calculus class. Today is Thursday, March 26th, and I hope you're all doing well. I'm going to start today with two requested homework problems from section 5.2, page 329, numbers 19 and 23. So we're still doing U substitution. So we're looking for the inside function here in our integral, and that would be 2x cubed minus 1. So that's our u value. We take the derivative of that, we get 6x squared dx. In our original problem, we have the x squared dx. There's the x squared dx in our du. There it is in the original problem. But in our du, we picked up a 6 that's not in the original problem. So we multiply by the reciprocal of 6, which is 1/6, and we put it in front of the integral. And then we do our substitution, which is u to the 4th power. And then the du takes care of the x squared dx. It does include a 6, but we took care of that by multiplying by a 1/6 on the outside. All right, then we integrate. So we add 1 to the 4th power, we get u to the 5th. Divide the coefficient 1 by 5, we get 1/5. And then we multiply 1/6 times 1/5 u to the 5th. And of course, we put in our plus c. All right, so 1/6 times 1/5 is going to give us 1/30. Our u is 2x cubed minus 1, so we take the u out, we put the x's back in, and we have that to the 5th power. So our final answer is 1/30 times the quantity 2x cubed minus 1 to the 5th power plus c. Now we're going to check that answer using differentiation. We're going to take the derivative. So if I take the derivative of this answer by chain rule, I get 5 times 1/30. I keep the inside function the same. I subtract 1 from the exponent, giving me 4, and I take the derivative of the inside, which is 6x squared, plus the derivative of the constant is 0. Then I just simplify this. I get 5/30, which is 1/6, which ends up being multiplied by 6x squared, so those 6's will cancel. And I'm left with 2x cubed minus 1 to the 4th power times x squared. And I just put the x squared in front of my quantity 2x cubed minus 1 to the 4th power, and I see, yes, this is the original integrand. So check, that's number 19. Okay, number 23, again, u du substitution, looking for the inside function, 3 minus 2x to the 5th power. That's my u. I take the derivative of that. Derivative of 3 is 0. Derivative of negative 2x to the 5th is negative 10x to the 4th dx. Looking back at my problem, I see I have the x to the 4th dx. There it is in the problem. There it is in the du. But I picked up a negative 10. That's not in the problem. So I need to get rid of that by multiplying by the reciprocal of negative 10, which is negative 1/10. And I put that in front of the integral. And then I write the rest of my substitution. So my u goes in the denominator, cubed. And in the numerator, you can put the du, but I prefer to put a 1 in the numerator and then just put the du out to the side. So now this expression says the same thing as the original integral using this substitution. All right, so now I'll rewrite the 1 over u cubed as u to the negative 3. And now I'll integrate. Bring down the negative 1/10. Add 1 to the negative 3, I get negative 2. Take my coefficient of 1, divide by negative 2. And then add a plus c. Multiplying this, I get 1/20, and I'll take the u out, put the x's back in, 3 minus 2x to the 5th to the negative 2 power plus c. And I could also write that as 1 over 20 times the quantity 3 minus 2x to the 5th quantity squared plus c. Now I'm going to check this, but I'm going to use this form right here with the negative exponent. It's easier to deal with. So I'm going to take the derivative of this and hope I get the original integrand back. So I have negative 2 times 1/20. Keep the base the same. Subtract 1 from negative 2, I get negative 3. Take the derivative of the inside, I get negative 10x to the 4th power. And then the derivative of plus c is 0. Simplify, I get negative 2/20 times the quantity 3 minus 2x to the 5th to the negative 3rd power times negative 10x to the 4th. So the negative 10 can be multiplied by the negative 2/20, which gives me positive 20/20, which is 1. And then what am I left with? 3 minus 2x to the 5th to the negative 3 power times x to the 4th. And that gives me 3 minus 2x to the 5th to the negative 3rd power times x to the 4th, which can be written as x to the 4th over 3 minus 2x to the 5th power cubed, which is our original problem. Okay, and that's number 23. All right, so now I have one more type of UDU substitution problem to show you, but let's just review for a moment. We've had two types of substitution problems so far. One where when we set up our u and du, the substitution matches the problem exactly. Like here in number 1. If I pick my u to be 3x squared plus 1, my du is 6x dx, which is the rest of the problem. So this perfectly fits, the substitution perfectly fits my problem. And I just end up integrating u to the 4th du. The second kind, which we just finished going over, is where in our du we pick up a number that's not in the original problem, so we multiply the integral by the reciprocal of the number we don't want. And that's this type of problem. X squared plus 1 is my u, and my derivative of that is 2x dx. Well, the x dx is in the problem, but the 2 is not. So my du picked up a number I don't want, so I multiply in front of the integral by the reciprocal of that number. So multiply by 1/2, and then I end up integrating u to the 4th du. Okay, that's the second kind. Here's today's type. What if the original problem has the numerical coefficient that doesn't show up in the du? Now we're starting with a number. We still pick our u the same way we did before. U is 3x minus 1, and then the derivative of that is 3 dx. But then when we go look at the problem, we're like, oh, we have a 2, but we picked up a 3. All right, well, what do we do when we have a number that doesn't match the number here that we picked up in our du? Okay, that's today's type. So we're going to look at that problem right now. This is that same problem I just talked about. So my u is 3x minus 1. My du is 3 dx. All right, so I don't want the 3. So we can do what we did in the previous problem. We can multiply by the reciprocal of 3 in front of the integral, which is 1/3. The 2 I can't do anything with. It's in the original problem. That's the way the problem was stated. I cannot get rid of that 2. So I'm just going to move it in front of the integral as well and multiply it by that 1/3 that I put out there. And so that's how I take care of the 2, move it aside, and get rid of the 3 with the 1/3. Okay, so that gives us 2/3 on the outside of the integral. And then I do my substitution. That's u to the 4th du. And I integrate. So I get 2/3 integral of u to the 4th du. And then I add 1 to the exponent, 5. I divide 1 by 5. I get 1/5. Multiply by the 2/3 that's out there and add a plus c. So I get 2/15 u to the 5th plus c. And then I take the u out and put the 3x minus 1 in. So I get 2/15 times the quantity 3x minus 1 to the 5th power plus c. And then I can check it, take the derivative of this. It would be, here's the answer. So 5, by chain rule, 5 times 2/15, keep the base the same, 3x minus 1, subtract 1 from the exponent, take the derivative of the inside, 3, plus the derivative of constant, 0. What does that give me? 10/15 times this 3 here, which is going to give me 30/15. And all I have left is 30/15 times 3x minus 1 to the 4th power, which is 2 times 3x minus 1 to the 4th power, which, check, that's our original integrand. Okay, I'm going to do one more of these for you. I think I am. Let me see. Yes. Okay, so here's the original problem. My u is x to the 4th plus 2. I take the derivative of that, I get 4x cubed dx. Well, I got a 4, I needed a 9. I can't get rid of the 9 because it's in the problem, but I can get rid of the 4. So, oh yeah, I forgot. I rewrote this as x to the 4th plus 2 to the 1/2 power. Forgot to mention that. Okay, so anyway, back to the problem at hand. All right, so I can't get rid of the 9 because it's in the problem to begin with. So and it didn't match my number over here in the du. So therefore I have to move it in front of the integral. I don't want the 4, so I multiply by the reciprocal of 4, which is 1/4. And then I'm going to integrate u by substitution to the 1/2 du. So I end up with 9/4. Integral u to the 1/2 du. I add 1 to the exponent, I get 3/2. Divide 1 by 3/2, I get 2/3. And I'm going to multiply that by 9/4 and then add in my plus c. So that gives me 18/12. I could have canceled. I didn't. I just did 18/12 u to the 3/2 plus c. 18/12 reduces to 3/2. And then I put the x's back in, x to the 4th plus 2 to the 3/2 plus c, and there's my answer. I can leave the check for you. I think you can figure out how to check this by now, so you don't have to check it unless you feel like you want to try and check that. That's fine. I have 2 problems like this for homework. One, they're both in section 5.2 on page 329. One is number 29 and the other is number 31. And so you can email me with any questions. And then tomorrow's video, I'll just post the answers. I'm not going to give a new video as far as a new topic. We will start section 5.3 on Monday, so you won't have an assignment over the weekend. So just do these 2 problems, and if you want to check the answers on them, if you don't get the answers and you want to see my work, I will do both of them on tomorrow's video. So you don't even have to request them. Tomorrow I'll do 29 and 31 for you. I hope you try them before I do them to see if you can get them, and then check in with the video tomorrow. And then that will be that. Okay? I hope you have a great day. I hope you're faring well and you're not too stressed out. Take some time to relax and get some rest, okay? And enjoy the sunshine and have a great day. Miss you guys. Bye.